Hello friends, welcome to Physics with Sanmitra. I am Sanmitra Bhomik and today's topic of discussion is sign convention in optics. Sign convention in ray optics. I don't know, there are many students who feel confused about this topic because what they try to do is that they try to mug up. They try to mug up the rules and they try to apply it. But that is not the proper process to do it because sign conventions are not meant to be mugged up. They have to be applied as per the situation. So I'm telling you a golden rule, that is never memorize the sign convention. Never memorize the sign convention. Now I will be showing you with the help of some problems how to apply sign convention in the problems of ray optics, so that you will never feel any problem how to relate the what you are reading in the book to what you are doing in the numericals. First of all, you don't follow any rule as such. You just apply it properly. That only I'll show you. That you just remember the simple things and you apply it properly. You don't need to remember so many rules. Okay, so let's begin. Okay, let's take a thin lens. And the focal length of the lens is say 5 centimeter, and an object is placed at a distance of 10 centimeter on the one side of the lens, and our task is to find image distance and nature. That is the nature of the image. Now, if we want to apply sign convention to this problem, let me tell you one thing. At the interface where there is reflection or refraction, you just draw an axis from there. See, this side, on the right side I am taking as positive x, and on the left side I am taking as negative x. Now, you can take the other opposite also. You can take the right as negative and left as positive. There is no such rule that will forbid you from doing that. But just for simplicity, because in our Cartesian coordinate system, the right side is actually the positive x-axis, right hand coordinate system. That is why I am taking that just for simplicity. Now, what is the formula for lens? 1 by v minus 1 by u is equal to 1 by f, where v is the image distance, u is the object distance, and f is the focal length. Now let me tell you one thing. This v, u and f, these are generalized variables. These are generalized variables. What do I mean by this term? That means the sign conventions are already inside it. You don't have to worry that this v is on the right hand side or left hand side. No, this v, u and f, whatever is there in the equation, inside that equation you don't have to worry anything. You put any value, that will automatically adjust because the sign conventions were taken care of during the derivation. But let me see here. Here the object is situated at a distance 10 centimeter from the say this is the optical center. An optical center it is corresponding to the origin. So the object is situated at a distance of 10 centimeter from the origin, and that 10 centimeter is in the minus x direction. So I can take u is equal to minus of 10 centimeter, minus 10 centimeter, and just see where the focal point of the lens lies. It lies on the other side, because if I draw a parallel ray, it will pass through the other focus on the other side and not the same side. So this focal point, it is given, it will be a little bit here. This is 10, so this will be 5. This is situated at a distance of 5 centimeter on the right hand side or in the plus x axis. So I can say f is equal to plus 5 centimeter. I think now it is very clear. Now let me find the image. Let's put the values. 1 by v minus here 1 by u. What will I put u? U is minus of 10 is equal to 1 by f. What is f? F is 1 by plus 5. So 1 by v will be equal to minus will plus, then again minus 1 by 5 minus 1 by 10. So v I will get as 10 centimeter. V I will be getting as 10 centimeter. So I will be getting an image at a distance of 10 centimeter from the optical center or the origin. So the distance here it will be 10 centimeter. Now regarding the nature of the image. Now how to find the nature of the image? The nature of the image, for that let me use another formula that is known as the magnification formula. M is equal to V by U for lens. Now since M is equal to V by U, what will I do here? I will put the value of V. V is plus 10 centimeter and U is minus 10. V is plus 10 and U is minus 10, and that will give me minus 1. So this will form an image which will be inverted, and it will be of the same size as of the object. It is minus will signify, the negative sign will signify that it is inverted. It is in the opposite direction, but the magnification is same. That means the size is same, and it is situated, and this plus V is equal to plus 10 centimeter, then the sign is plus here. That signifies it is at the right hand side. So you will not memorize anything here in this case, but you will correctly apply the sign convention here, and you will just look from the axis, it is minus or plus, and you will put in the formula. Then you will get the answer. So the nature of the image is, I can write here, that is real, since if I can see from the ray diagram they are converging, so it is real. This is a focus. It can be formed on a screen. Real, inverted and of same size. Okay, now let's look at the next problem. Now we have the same lens with focal length 5 centimeter, but I am placing the object, say, at f is equal to, let's say we are placing the object as f is equal to 3 centimeter, not f, u is equal to 3 centimeter. U is equal to 3 centimeter from the origin. Now what will be the image distance and the nature of the image? Now how to find? See, we have already shown you that f is at a distance of 5 centimeter. Now let's do one thing. Let's draw the axis. This is minus x, this is plus x. Now just like the previous example, we know u will be equal to minus 3 centimeter since it is in the minus x direction, and f will be in the positive plus 5 direction. Now we can find 1 by v minus 1 by u is equal to 1 by f, implies that 1 by v minus 1 by minus 3 is equal to 1 by, what is f? F is plus 5. By solving this we will get v is equal to, minus of 7.5 centimeter. Now what does this mean? The image is actually forming in the backward direction. The image we are getting in the backward direction, that is, it is at a distance of minus of 7.5, that means 7.5 centimeter in the left hand side. Now if it is forming at a distance of minus 7.5, that means it cannot be a real image, because the rays, because there is no reflection, there is refraction, the rays will actually go like this. So I have to backward produce it. To get the idea of the image. Let me draw it properly. This is such a case that if this is my object and this is 3 centimeter and this is focal length, this is 5 centimeter, and the image is forming somewhere here, that is at 7.5. Therefore I have to at first see these rays are diverging, therefore I have to backward produce it, then only I will get an image. And from the ray diagram I am getting from the ray diagram I am getting that it is erect and magnified and unreal, because it is not real. These rays will never converge. So V I got minus 7.5 centimeter, U was minus 3 centimeter. So if I find out M, that is the magnification, that is V by U, that is minus 7.5 by minus 3, and that will become my 2.5. So the image is 2.5 times magnified. I think this much is clear. Now one more problem I will solve, and that will clear your concepts even further. Here we have a spherical glass ball, and inside the glass ball there is a object that is, say, O. There is an object that is O, and an observer is watching from this side. Now the radius of the glass sphere or the glass ball is 10 centimeter, and the refractive index is 3 by 2. Now we are asked to find the distance of the image. Find distance of image as seen by the observer. Here is the observer, OBS. Now let's see how to apply this. First of all, what we have to do, we have to define the axis. How to define the axis? This is how we define the axis. Let's say this is y, and where we will put the origin. This is a trick. See, if you don't put the origin there, then also you will get the correct answer. But if you put the origin there, then the calculation will be very easy. At this point, I am putting my origin, because if I put the origin here, the calculation will be very easy. Otherwise, you can do it anywhere. You can put the origin anywhere on the x-axis, on the y-axis, anywhere. You will get the same value. But why to unnecessarily do more calculation? Okay. Now see the object. This is the object. This is my U. This is situated at a distance of, say, this radius is 10 centimeter. So 10 plus it is 5 centimeter. It is situated at a distance 5 centimeter. 10 plus 5, that is 15 centimeter. This is situated at a distance of 15 centimeter, and it is in the plus x direction. This is in the plus x direction. So I can say U is equal to plus 15. Okay, let me write down the formula. What formula we use for the diffraction at curved surface? For diffraction at curved surface, the formula we use is mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. See, here this is the surface 1, here this is the surface 2. This is the medium 1, medium 2. Medium 1 is my air, medium 2 is my glass, and mu2 and mu1 are the refractive indexes of medium 2 and medium 1 respectively. V is the image distance, U is the object distance, and R is the radius of curvature. Okay. Now U is plus 15 centimeter, and what is my, see, I don't know what is V. I will find out V. I know what is mu2, what is mu1. Mu2 is, see, mu2 will be here 3 by 2 and mu1 will be here 1. Now what I can do here, mu2 and mu1 I have already found out. Now FR, let's see the radius of curvature. See, the radius of curvature, if I see, this radius is actually going this side. The sense of the radius is this side. So I will take radius of curvature as plus, the radius of curvature I will take as plus 10 centimeter, not minus 10 centimeter. Had it been like this, the radius is sensing inward, then I would have taken minus, but that is not the case here. So I will take radius of curvature as plus, because the radius is actually like this. So if I put the formula, put the values here, see this formula, what is mu2? Mu2 I can say, mu2 is 3 by 2. 3 by 2 by V. V I don't know. I will keep it like that only. I will get the answer after solving. What is mu1? Mu1 is 1, air. What is U? U is plus 15. See, this is the first time we are in the 3 examples we are doing a problem where the u is coming as positive, that is why I chose this question. Now is equal to mu2 minus mu1. What is mu2 minus mu1? 3 by 2 minus 1 by r is plus 10. If I solve this, I will get v is equal to plus 20 centimeter. V is equal to plus 20 centimeter. Okay, now let me show you what actually it means. See, this is my glass sphere and this object is kept at a distance of 5 centimeter from the center, and this is my origin. Don't forget, this is my origin. Now this is located from the origin. The image will be located at a distance of 20 centimeter. That means here. This is my object O. This is origin, origin, origin. It is not O. This is my object O. This is my object image I. Okay. Now this is 20 centimeter. Now if you are asked to find the image distance from the center of the glass sphere, then you have to take it as 10 centimeter. Many students make this mistake. They take the origin as somewhere else and they take the image distance from something else when asked from center. Okay, so that's all for the sign convention video. I hope you have understood and the confusion is clear now. If you like our content, then please share our video and subscribe to our channel, and please join our Telegram group. The link is given below. Thank you.